Dear students, we already discussed about the reflection of light, and we had discussed also the spherical mirrors and the plane mirrors and the image formation by these mirrors, type of mirrors. Now in this video we'll discuss the next topic of this chapter, that is the refraction of light. See what is the refraction of light and see what is the difference between the reflection and the refraction. In reflection and see the difference between the refraction. In reflection, ray of light when incident on a surface, it returns into the same medium, okay, with the same angle also. But here the ray which is incidenting on the surface transmit or passes to another medium, okay. So main difference is that in reflection the ray of light returns into the same medium, and in refraction the ray of light passes into the another medium, okay, from one medium to another medium. Here the medium is changed and the speed of the ray of light also changed, and you can see there is a bending of the ray of light. Ray of light always bends towards or away from the normal. So if you try to give the definition of refraction, you can give the definition like this: the bending of light while passing from one medium to another medium is called refraction of light. Okay, now this bending of light depends on the density of the another medium. First medium, this is the second medium. So there are two types of medium, that is the denser medium and the rarer medium. Denser medium and the rarer medium, two types of the medium. Okay, rarer medium where the particles of the medium are at much distance, they are not very close, and the denser medium where the particles of the medium are very close to each other. If you take the example of the air and the water, so water molecules are much closer in comparison of the molecules of the air. So air is the denser and the water is the rarer medium. Okay, if we take the another example of glass, so glass is, the particles of the glass are much closer in comparison of the water. So here now it is the denser medium, and the water in comparison of these two will become the rarer medium. Okay, so rarer and denser medium depends on the two medium which are given for the refraction. Okay, and remember, for as a rule, if a ray of light passes from rarer to denser medium, it always bends towards the normal, and if the ray of light passes from denser to rarer medium, then it bends away from the normal, always away from the normal. Away means from this angle will increase. So remember, it means the speed here decreases when ray coming from rarer to denser medium, but when the ray is coming from denser to rarer, speed increases. So speed here decreases, and here the speed increases. Okay, this is the difference between these two types of the medium. Now, as we had discussed laws of reflection, here there are two laws of refraction also. See the laws of refraction. There are two laws. The first law, incident ray, refracted ray and normal all lie in the same plane at the point of incidence. Okay, see the example. This is the incident ray incident ray, and this is the refracted ray. This is the refracted ray. Okay, and this is the normal. This is the normal. All lie at the point of incidence here. Okay. Second is, this angle is angle of incidence and this angle is the angle of refraction. So the second law, which is known as the Snell's law, according to it, the ratio of the sine of the angle of incidence, the ratio of the sine of the angle of incidence to the sine of angle of refraction is always a constant. So write in your sentence, the ratio of the sine of angle of incidence to the sine of angle of refraction is always a constant, and this constant is known as the refractive index of the second medium with respect to first medium. It is called the refractive index of the second medium. This is the first medium, this is the second medium. So you are getting the refractive index of this one. So this is known as the refractive index of the second medium with respect to first medium. Okay, suppose here air, here is the water. So refractive index of water with respect to air, like this. Okay, this is called the Snell's law. So using the concept, remember these are very important laws. So using these laws and the property of the medium, we can discuss the refraction through a rectangular glass slab. See the next topic, refraction through a rectangular glass slab. Okay, how the refraction takes place. If we see this glass slab, this is a normal, suppose the ray of light coming from the air. Okay, suppose this side is the air, this is the glass. Okay, this is the glass. So when a ray of light comes from rarer to denser medium, then what will happen? Already discussed it here. It will bend towards the normal. Okay, because ray is coming from rarer to denser medium. Now draw another normal here. Now ray has to come. This is the rarer medium, this is the denser medium, and this is the again rarer medium. So ray has to come again from denser to rarer. So its speed will increase and it will bend away from the normal. It will bend away from the normal like this. Okay. So this is the refraction takes place in case of the glass slab. If we increase this line, you will see these two are parallel to each other. These two are parallel to each other always, because the medium of both sides is same. This angle is known as the angle of incidence. This is the angle of refraction, and this angle is known as the angle of emergence. And this perpendicular distance, you can say here any name you can see. Suppose the O, this is the L. So OL is known as the lateral displacement. Lateral displacement. Okay, lateral displacement. So this is the refraction through the glass slab. Okay. Now on the basis of this, here we can find sin I upon sin R, that is the refractive index. If we talk separately about the refractive index, then how we can define it? The refractive index. Okay, that is this one. It is the refractive index of the second medium and the first medium. So refractive index is defined as the refractive index of second medium with respect to first medium. It is the speed of light in medium 1 upon speed of light in medium 2. So medium 2 means, suppose rays coming from air to glass. So refractive index of the glass is equal to the speed of light in air upon speed of light in glass. Okay, this is the first medium, this is the second medium. So we always find the refractive index of the second medium. So this is the another definition. Or suppose the rays coming from any medium from the air. You know the speed of light in air is considered as c, that is the 3. C is equal to 3 into 10 to power 8 meter per second. You know this value. And speed of light, suppose in a medium, is v. So this refractive index is c upon v. And remember, if I ask why it is always refractive, remember refractive index is always greater than 1 with respect to air. Why? Because c is the maximum speed, possible speed, and the v is always less than c. Okay, since v is always less than c, therefore refractive index of any medium with respect to air is always greater than 1. Always greater than 1. Remember this fact, very interesting fact. Okay, because c is more, v is less, so this value is always greater than 1. So this is the reason why the refractive index of any medium is always greater than 1. Thank you, friends. In next video we are going to discuss about the refraction by the spherical lenses.